What are convection currents and how do they work? Imagine a pot of water boiling on the stove. You see bubbles rising from the bottom to the top. That movement is a perfect example of convection currents in action. These currents are all about how fluids move when they are heated and cooled. They happen in liquids and gases, which means air and water are always involved in these natural flows. Convection currents start when part of a fluid gets heated. When this happens, the molecules in that area move faster and spread apart. This makes the heated part less dense than the cooler parts around it. Because it is less dense, the warm fluid begins to rise. As it moves up, it transfers heat to the cooler areas above. Meanwhile, the cooler, denser fluid sinks down to take its place. This creates a continuous loop, or cycle, of rising warm fluid and sinking cool fluid. This cycle is what we call a convection current. It is a way for heat to move through a fluid without needing direct contact. Think of it as a natural conveyor belt, moving heat from one place to another. Convection is one of the three main ways heat transfers, along with conduction and radiation. Conduction is heat transfer through direct contact, and radiation is heat transfer through electromagnetic waves. But convection involves the bulk movement of the fluid itself, which makes it very effective for transferring heat over larger distances. In the real world, convection currents are everywhere. They heat the air above a fireplace, making the room warmer. In the ocean, they distribute heat across vast areas, affecting weather and climate. Inside the Earth, convection currents in the mantle cause the slow movement of tectonic plates. When you boil water, the hot water rises and the cooler water sinks, creating a steady flow that cooks your food evenly. Understanding convection currents helps us see how heat moves naturally in our environment and in many devices we use daily. They are essential for weather patterns, ocean currents, and even how our homes stay warm or cool. These currents are a simple yet powerful way nature moves energy, making them a key part of how our planet functions.